In this video, I'm going to show you how to create a polygon of arbitrary shape like this blue line that you see here and identify all of the XY coordinates that are specified inside that polygon. So you can see there's a bunch of red plus signs scattered all over the place. And then we have a bunch of plus signs inside the polygon, and those are marked in green. So basically a figure like this is going to be the end result of this video. Now I'm going to walk you through this one step at a time, and anytime you feel like you can jump one step ahead of me or multiple steps ahead of me, then you should definitely pause the video and try to work through the code on your own as much as you can. And then of course you can come back to the video and see how I solved the problem. Okay, so this is a multi-step problem. So let's see. The first step that we need to do is to generate random dots, and I want to generate them such that the x values are arbitrary and the y values are arbitrary. So I want to be able to specify that the dots are randomly scattered between any x values and any y values that I specify. Okay, so we need to generate all the random dots, and then we need to draw a polygon. And that's going to be this blue shape here. And of course, it can be whatever shape you want it to be. And then after drawing that polygon, we need to identify the dots inside the polygon and plot. All right, so let's get started. So we need a couple of parameters. We'll specify the number of dots. Let's see, num dots. And let's make that, how about 432? Because a round number is boring. And then we need to specify the x range and the y range. So by x range and y range, I'm referring to the smallest x value and the largest x value. So you can see in this particular case, this has an x range of -100 to +400. So let's go for, how about x is 0 to 456, and here the y range is, I think I set this up to around 830 or 840. Let's set, in this case, the y range to go -235 up to, how about 555? Why not? And then I often like to use spaces to make things look a little bit more visually aligned. Okay, so these are some of the parameters, and now we need to create the dots. So how do we create the dots? So what we are going to do is use a sparse representation. So I'm going to generate a list of coordinates. So it's going to be a 432 by 2 matrix. So 432 rows and 2 columns, each row corresponding to the XY locations of each of these dots. So to start with, let's say that the dots equals rand num dots by 2. Okay, so far, I'll run this code. So far, what we have is a collection of dots, or I should say XY coordinates. However, because I use the function rand, all of these coordinates are scaled between 0 and 1, uniformly distributed between 0 and 1. So what we need to do now is normalize the first column of dots according to this range, and then normalize the second column corresponding to y values according to this range. So this would be a great place for you to pause the video and try to figure out how to normalize these values, which range from 0 to 1, to get into this range and this range. So there's a couple of different ways that you can do this. I'm going to say dots, all rows first column, so this is going to be the x values, equals themselves times, and now what we want to do is basically subtract this second value from this first value, and then add on the first value. So let me actually write some code. I'll write this whole normalization out, and then I'll go back and explain. So I'm going to say times x range 2 minus x range 1, and this can actually be simplified just by saying diff x range plus x range 1. Okay, so now I'm going to run this code. So I ran all the code in this cell by pressing Control Enter. Didn't see any errors, didn't see any warning messages. That's already a good sign. So I'm going to open up a new figure and plot the dots. So this is now, I'm just plotting the x coordinates here. And you can see that the x coordinates for the dots range from 0 up to a little bit under 450. Or maybe this one goes up to 450. Let's see, actually I can say min dots all comma 1, and then max is 455, just under 456. Now you might be wondering why the smallest value is 0.4 and not 0. And that's because the way that I set up this normalization factor here assumes that we are normalizing a range that goes from 0 to 1, and we're normalizing 0 to 1 to 0 to 456. And so by chance, because these are randomly sampled numbers, it's just very unlikely that you are going to get an original x value coordinate of exactly 0 and exactly 1. And so therefore, in the normalized result, you're not going to get exactly 0 or exactly 456. Okay, so now I repeat this, copy paste, and now this is for dots 2, so that's the y coordinates. This, of course, also has to be changed. This becomes the y range, and this is also the y range. All right, and now we want to make a plot. So I'm going to say I'm going to put this in figure 2 because I already have the result here in figure 1, and I'd like to refer back to this a little bit later in the video. Okay, so this is going to go in figure 2. I typically clear the figure just to, in case there's any other graphs that are already held on the axis. So clear the figure, and I'm going to say plot the x values by the y values. And actually, let's just try that already. Okay, so you can see it looks like a chaos of lines. And what's actually happening is that there's all the dots and there's straight lines being drawn between the dots. But I first want to draw your attention to the x and y axis ranges. You can see this goes from 0 to around 450. And the y-axis goes from looks like minus 250, or I guess it should be around 230, up to plus 550 or so. So that looks pretty good. And now let's see if we can make this better. So the other plot, I had plus signs. So there you go. Now there are plus signs. And I had them as red plus signs. And now you can see these plus signs are a little bit smaller. These are larger and thicker. So the way that I made them thicker is by specifying the line width to be, I think I used a value of 3. Yeah, so now they are thicker, but now they're a little bit small for the thickness. So what I'm going to do is also increase the marker size. Let's say marker size, and how about 15? Okay, so that looks pretty good. And I think these are a little bit smaller. So maybe I had previously used marker size of 13 or 14. Okay, so I would say that completes this first section, except for comments. It'd be nice to have some comments in here. So these are some of the initial parameters. And now here I'm generating randomly placed dots. And here I am normalizing the XY locations for the, I should say, according to the parameters. And then here we plot the dots. Good, so the next step is going to be to draw the polygon. And just as a quick reminder, that's this guy here, this blue contour outline here. And again, if you think you know how to do this, or how to draw some arbitrary polygon using the mouse and mouse clicks, then I encourage you to pause the video and have a go at this yourself. If you want a little bit of a hint, the hint is to try to use the function ginput. That's going to be the main function that I'm going to use here. All right, so the ginput function, there's a couple of different ways that you can use it. So I'm going to say the output will be y comma x equals ginput, and just like that. So now let's see, when I run this line of code here, now we get this crosshair in here. And now I'm going to left click around and nothing really is happening. It looks like nothing's happening. I'm left clicking, left clicking, left clicking. And now I'm going to press the Enter key in the keyboard. And now the crosshair disappears. And now you can see who's X and Y. So now we have 13 X values and 13 Y values. And that corresponds to 13 clicks. So I made 13 clicks. And now I can actually plot this. I'm going to say, hold on, and then plot X comma Y. And let's make these green circles. Okay, so I hope you can see this. It's a little bit faint, but these are all the places where I clicked the mouse. Okay, so that is one way to use ginput. Another way to use ginput is to specify the number of clicks that MATLAB should be open to. So for example, I can say ginput 2, and now when I run this, it's going to give me 1, 2 clicks, and then you can see the crosshairs disappeared on their own. And now X and Y are 2 element vectors. So with that as background, the idea here is that we want to be able to click and move the mouse around and continue left clicking until we are finished. And then what I'm going to do is put this inside a loop. It's going to be a while loop. And basically we want to keep clicking until the user presses the right mouse button. Okay, so how do we know whether the user pressed the left button or the right button? That is given by the third output called button. So now I'm going to say ginput 2 and with 3 outputs. So you can see 1 here and 1 there. And actually, I wanted to use the other button. Okay, so I'm going to run this again. So we do left click, and then the second one was a right click. And now you can see we have 2 values for X corresponding to 2 button clicks, 2 mouse clicks, 2 values for Y for the Y locations, and button is a 2 element vector and it's 1, 3, and that's because I clicked left and then I clicked right. And on my mouse, I have a middle mouse button, so the right button is actually number 3. All right, so here is how it's going to work. I'm going to specify while button equals 1, and then we want to get a new X and Y input. And this is just going to be, let's see, 1 mouse click at a time. So it's going to look like this. Now, the first time you run this code, this is actually going to give you an error because I haven't defined the variable button. So I need to say button equals 1. And that's just going to make sure that we get inside this while loop with no errors. Okay, so now I can run all of this code. And that kind of works. It seems to work. I'm left clicking and I keep getting more crosshairs. And now I'm going to right click and that's the end of the crosshairs. So that's good. However, this code didn't actually save all of the mouse clicks that I made, all the locations. It kept overwriting X and it kept overwriting Y each time this loop was called, or each iteration inside this while loop. So therefore, what I'm going to do is create 2 new vectors, and basically that's going to be added on top here. So let's see. I'll call these X and Y, and I want to specify that both of these are going to be empty. So these should be 2 empty vectors, and then the idea is in here, let's call this xt and yt for xtemp. So then x is going to equal itself with xtemp concatenated, and then same thing with y. So y equals itself, and then concatenating onto the end of it the most previous value of yt. Okay, so you can already see that we're getting an error here, and that's because MATLAB doesn't like this format. It's not possible to equally distribute this one empty vector into these 2 outputs simultaneously. So you could do this on 2 lines. You could say x equals empty, y equals empty, but there's another option. You can use the function deal, and the function deal will distribute or deal out the input into however many outputs. So now we have x is empty and y is empty. Okay, so now I'm going to run all the code in this cell by pressing Control Enter. And I'm going to just click around a few times with the left button and then click once with the right button. And now xt and yt are only 1 number. However, x and y are in this case 10 numbers because I must have clicked 10 times. Now, so far, that kind of does what we want. That's going to draw the polygon. However, there's no visual feedback, so it's kind of, it might be hard to remember exactly where you've drawn this polygon. It would be really nice if you could have lines going on top of this image as I'm drawing the polygon. And I'll go back here, so I'm not drawing on top of the other one. Again, this would be a great time to pause the video and figure out on your own how to draw a line as I'm clicking on each dot. All right, so what I'm going to do is say, hold on, and then I'm going to plot. And now actually what I want to do, let me foreshadow a little bit here. So I'm going to get a new mouse position. And then here, I'm going to update a plot handle. Now, whenever you're drawing animations or dynamic plots in MATLAB, it's always a good idea to use plot handles. They're faster and they are smoother. So what we want to do here is say something like set a plot handle. Now I haven't created this variable yet. I'm going to create this in a moment. And what do I want to set? I want to set the x data to be the new x and the y data to be the new y. Okay, so now we need to create this plot handle. So I'm going to say plot h equals plot. And now up here, I don't have anything to plot yet because I haven't drawn any part of the polygon yet. So really all we need is some dot that's somewhere in this range. So I'm going to say plot the average of the x range by the average of the y range, and let's make that a blue line. And this is actually just going to plot a single dot here. It's going to be basically invisible, but mostly I really just need this plot handle. So if you're not familiar with working with plot handles, then it's something like this. It's a special type of MATLAB variable, and essentially it allows me to adjust the properties, the visual properties of a line. So you can change the color. You can see the color here is RGB, so it's basically just a blue line, which I specified here. Here's the line style, the line width, and in particular what I am interested in is the x data and the y data. So here these are just single numbers, and so this just corresponds to a point at the center of this graph. But now what I do is I update the plot handle, I update the x data, and I update the y data. And in fact, I can even show you this because I've already drawn some of these dots. So here you go. Now this is outside the range here because when I was actually creating this, I did it based on this figure, which has a different XY range. Okay, so let's try again. I'm going to generate new dots, make a new plot, and now I'm going to run all the code in this cell. And now I should be able to draw out some region like this. And let's say it looks like this. Oh, maybe I don't feel like including those dots here. I'll get these, I'll draw, I don't know if I should include this one. I think okay, I'll include it. All right, so these were all left clicks. Now I'm going to do a right click, and that's going to end this while loop because now the value of button is actually 3. And by the way, the last button, the last mouse click, even though it was a right mouse click, that still gets included here. And that's because this Boolean test, whether to stay inside this loop, happens all the way up here, and any code that's still in here is still going to get run. So I ran this code. The last time when button equaled 3, that still updated x and y. Now, in this particular case, I think that's fine. But if that's not what you need, for example, if you don't want the final right mouse click to be included in this list, then you will need to make some adjustments. Maybe you can add a new line here that says, if button equals 1, then update the x and y. It's one way to solve it. All right, so this is looking pretty good. We are getting pretty close. The last thing we need to do is to identify all the dots that are inside this polygon and then plot them. Now, if you were just drawing a rectangular region on this graph, so identifying coordinates within some rectangle, then that part would actually be pretty easy, particularly if the rectangle is at the edge. You could say any dot any location, any coordinate that has an x value of less than 100 and a y value of less than minus 25, then call that a target. So that would be a pretty straightforward way. This one is a little bit more challenging because it's not so easy just to say, x is less than 300 and greater than 160, because we need all these contours in here. So I'm going to give you a hint. The hint is that the function I'm going to use is called inpolygon. It's a pretty aptly named function. So you might guess that it's going to determine whether some points or set of points is contained inside some polygon. So now again would be a great time to pause the video and try to figure out how to identify all of these dots here, all these coordinates inside this polygon using this function inpolygon. All right, so now the solution isn't too difficult. You basically just have to look up the help file for inpolygon and test a few things. So it turns out that the way to solve this is by giving 4 inputs into the inpolygon function. And those 4 inputs are the x coordinates, the y coordinates for all the dots, and then we need a set of x and y coordinates that define this polygon, and that is just x and y. So comma x, comma y, and then the output is going to be dots in. So the output is then a Boolean vector. So you can see this is type logical or Boolean. It's 432 elements. That corresponds to 432 dots. And by dumping this out, you can see that it's all zeros and ones, which is actually falses and trues. So that means that these coordinates here are inside the polygon and these coordinates are outside the polygon. Okay, so then the final thing we want to do is plot let's see, this is a green ring. So we're going to plot a green ring around these dots. So that's going to be, and actually I think I'll copy and paste this because some of this is going to be similar. Now the thing is, we don't want to plot all of the dots. We want to plot only the dots where this is true. So we want to say dots in. Now you could also say dots in equals 1, but because this is a Boolean vector, we do logical indexing here, so this in fact does the trick. So dots in, and now we don't want these to be red plus signs, we want these to be green circles. And let's see what happens if we keep the marker size and the line width the same. All right, brilliant. This looks really good. So now we have successfully completed this assignment. I hope you pause the video several times and work through a lot of this code on your own. So code like this in general, this is, it's kind of fun. It's just a little bit fun to do this. But this also does have some practical implications if you are doing some video tracking and maybe there is a target that is moving around the video and you want to know when does that target move inside some important region, then this would be some way to do it. This would be one method that you could do this problem of identifying when a target is inside a user-defined region of interest.